All right. Uh, a medication is administered to the patient. The amount in milligrams that medications in the patient at time t hours is modeled by the function y equal at. But we don't know what it is. But only its differential equation is given. With respect to time t, right, derivative looks like it changed this way. 12 minus y over 3. At time t equals 0 and 0 milliliters. That means they're going to start from at x equals t is 0 and the amount of medication is 0. Maybe you can start from here. That is the initial conditions kind out. Okay, that is the initial. Okay, the first questions there. A portion of slope field for differential equation dy over dt equal, yeah, that is given, sketched out. This time's a little, okay, different questions, okay. So we need to sketch the solution curve through what? 0 and 0. But this times, you don't have to write out accurate graph, just approximate graph is okay. All right? Yeah, that's the solutions. So we start from 0 and 0, okay? This is initial condition here. So follow their slope over here, okay? The graph slope follow the graph looks like this one. Approximate and over here close to 0, right? Slope is 0. That's okay? Yeah, that is the graph of y equal f over t. Okay? You can solve this one. But this is okay too, approximate, this is okay. Anyway, the graph looks like this way, okay? All right. Just approximate graph is okay. Yeah, number 8, no problem, okay? If you have initial value up here, we start from here. The graph looks like this one. Follow the graph. This is will be a solution of that differential equation. Okay? It depends on if you start from here. The graph looks like this, okay? Just follow the slope, okay?
Yeah.
You know what I mean? But this time we start from 0 and 0. The graph will follow the slope over here, okay? Yeah, finally it goes slope is 0, okay?
Yeah.
Okay, now that is number 1. Number 2, using correct unit, interpret statement limit at when t is close approaches infinite. That is 12. That is what the amount of medication is 12 millimeter, right? They said 12 milligrams in the patient, okay? 20 milligrams in the patient. So how can you express this one? When t go to infinite. How can you say this one? The limit just over here we got limit t go to infinite at solution equals 12. What that means? Follow this graph. When t go to infinite, the approach is what 12. That is the valuable amount of medications. Okay? Over a long times, in the long run, right? In the long run of time, the medication, the amount of medications approaches. That's right. Okay, limit means approach. We use this rate. Okay, approaches. The amount is 12 milligrams. Okay, that's enough. That's the meaning. Okay. So they approach milligram. Maybe that's this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 milligrams. Oh, that's correct, okay?
Yeah.
Gotta get increased, but never touch 12 milligrams, but approaches 12 milligram, okay, in the patient. This number B is okay, right? You can interpret this way. The third one, use separation variable. In high school, only what DE, difference equation, can be given, okay, only by using separation of variable, okay? So the DE means what? Difference equation should be separable. That's why we use separations. The particular solution, the difference equation, okay, at 0 and 0, we're going to find the graph of this one, okay?
Yeah.
What is this? The solutions of these differential equations? We have to solve this one, okay? Now separable. We need separate, okay, y to the y, x to the t to the t, okay? But we have a 12y there. Maybe you can multiply time there. dy equals how much? 12 minus y and over 3 dt, right? But this one has a variable y. This variable y going to the left, right? That's just separable, okay? So you can divide 12 minus y both sides. So look like this one. 1 over 12 minus y. Or you can switch about y and 12, it doesn't matter, okay? But sometimes you better use y switch, okay? But it doesn't matter, nothing different, okay? You can use this one too. 1 over 12 minus y and dy equals, we still have a 1/3 t, right? 1/3 and dt. This we set separable. The equation can be separable, okay? Now when you separate, okay, or variables, the process, right, this equation is, we said, what, separation, okay? So now we're gonna find out, okay, integral, okay? So I'm going up, you start from here. 1 over 12y minus y and dy integral equals to 1 over 3 dt integral, okay? You start from here. What is the antiderivative? Is 1 over 12 minus y. Y minus 12 over 1, antiderivative, what is it? ln y minus 12. Is it okay?
Okay.
Yeah. But this one, that's why, okay, we have to use this one, okay? 12 minus y, 12 minus y, this is antiderivative is what? ln epsilon by 12 minus y, but take integral of negative y is negative 1, right? So we put the negative sign there. That is antiderivative.
Yeah.
Okay, that's why to avoid confusion, okay, I like to use, okay, y first. So you can, if you have this question, try to this way first. dy equals, switch this one, okay, 12 and minus y are negative 1/3. That's right, one more negative sign, and inside is what? Y minus 12 dt, okay? But this is the y first, second is okay, all right? This is a little easier than before. So I'm going to change this one. You can do this way, it doesn't matter, okay? But a little avoid what 2 minus sign there. So y minus 12 is moved to the left. 1 over y minus 12 dy equals negative 1/3. Now, right hand side is negative sign, okay? Negative 1/3 times dt, and take integral. That is better. Okay? That is better. So this is a minus sign over here. This is a y minus 12 here. This is, we got one more negative sign, okay? It's the same thing, isn't it?
Yeah.
Now, antiderivative, the first one, y minus 12, 1 over y minus 12 is ln y minus 12 epsilon value, okay?
Yeah.
It is okay, all right. And the right-hand side, negative 1/3, there is a constant, negative 1/3 of t plus c. Okay? Now let's find epsilon value y minus 12. Exponent form is what? This is e there, ln e. This is e to the what? Negative 1/3 of t and the plus c, isn't it?
Yeah.
Okay. So epsilon value is plus minus y minus 12 equals what is that? Plus minus e to the what? Negative 1/3 t and the plus c is what? E to the c, right?
Yeah.
E to the c is a constant. So I'm going to tell you T1. E to the C1 is a constant. Put this number to the front. Plus minus e to the C1 and e to the negative 1/3 of t. But still this is a constant. Is it okay?
Yeah.
Plus minus e to the C constant, right? E to C is a constant, plus minus is just a sign, total is a constant. You let this is a C, okay? Let this is a C, final C. So y minus 12 equals what? C e to the negative 1/3 t. That's it. Okay? Now, express y. Now you got the y over here. C e to the what? Negative 1/3 of t and plus 12. Okay?
Okay.
Now we decide the value of c there. Okay? What is the value of c? When t equals 0 over here, y equals 0. Okay? Put this number y equals 0, t equals 0. T to the 0. 1/3 times 0 still 0 and plus 12. But this is 1. C plus 12 equals 0. From here we can see that C equals negative 12. Are you okay with this?
Okay.
Alright. So put this number there. Y equals, I'm going to write that this is first. 12 minus, and 12 C is negative 12 and e to the 1 negative 1/3 over t, right? That's the solutions. Okay? Yeah, that is a particular solution, right? Which is for the initial value satisfy these initial conditions. It's okay?
Yeah.
That's the solutions. C. Oh, another one more over here. Choice D. A differential procedure is used to administer the medication to a second patient, or a different patient over here. The amount in milligrams of medication in second patient at time t hours is measured by the function y equals bt. New one, not at, a little different, because it depends on people, right? Satisfy differential equation. Now, this time dy dt differential equation is what? 3 minus y over t plus 2. Just before, almost same. Here, 12 minus y over 3. Oh, different, right? Yeah, totally different. But this time in this condition at t equals 1 and y equals 2.5 milligram, okay? When t equals 1, y equals 2.5 milligram. That's the initial condition.
Yeah.
But not initial, okay? Initial means what? T equals 0, right? But this is anyway conditional, okay? Satisfy this one. Is the rate of change the amount of medication in second patient increasing or decreasing? This rate already, right? This is the rate already, right? Dy dt is what? Rate. Okay, slope. It's already slope. But this rate, we're gonna change, increase, decrease means what? Second derivative, we have to check, right?
Yeah.
For example, what? If f of x is f of x increasing,
Okay.
no, different question, okay? So we're gonna check f of x, right? Derivative. Derivative of this one is what? Positive, that is increasing. F prime x is a negative, that is decreasing, right?
Yeah.
But now this is a derivative again. So I'm going to say f of x, we're going to find increasing or decreasing. We're going to check this one. These are our questions, not this one, okay? F of x is increasing or decreasing. How can you check? It's a derivative again. The derivative of first derivative is about second derivative, right? Second derivative is positive, that is increasing. Second derivative is negative, this is decreasing. Okay? F prime x is decreasing. That's the meaning. Are you okay with this?
Yeah.
So this dy dt, we check, right? Dy dt is increasing or decreasing. Okay? When? At time t equal 1, at these times. At these times 1, dy dt, our questions over here. Dy dt is increasing. Okay, this is the question is dy dt increasing or decreasing? That's the questions. So how can you check? This is first derivative. To check increase, decreasing, we need what? Second derivative, right?
Yeah.
Okay, we need to find the second derivative. Okay, now take a look second derivative of your second derivative dt d. Okay? First derivative 3 minus y over t plus 2, right? Okay, we take a derivative again. Okay, now let's find the derivative of it. Derivative of constant is 0, okay? So what is derivative of this one? Okay, minus out. Okay, minus is out. Y dt, but it doesn't matter.
Yeah.
Take a derivative of this, okay? Negative y over t plus 2. What is this? Quotient, right?
Yeah.
This is a 0 with, it doesn't matter. So denominator is squared, okay? T plus 2 squared. What is derivative of numerator? Y prime, it's okay?
Yeah.
That is y prime is dy dt, okay? I'll go with this, so dy dt times t plus 2 denominator, right?
Yeah.
And you probably minus sign outside of it, okay? And the second one is minus, don't touch y. But we multiply derivative of what? Denominator, okay? What is derivative denominator? T derivative is 1, it's okay? Right, that's it. So dy dt is this one. Okay? Now put this number in there. Minus over here. Dy dt is what? 3 minus y over t plus 2. That is dy dt, right? Replace this one. And times dt plus 2 again. And second one is what? Y. Okay? Now denominator t plus 2 squared. That is the second derivative. Look at this. Y is the function of t, right? Yeah, dy dt. Now put this number t equals 1 there, okay? When t equals 1, what is the value of y? Over here. T equals to 1, y equals 2.5. Are you okay with this? It's already over here. Put this number t is 1, y equals 2.5, okay? So minus 3 minus y equals 2.5. T equals what? 1, right? 1 plus 2 is 3. and t equals 1, and 1 plus 2 is 3 again. And y equals what? 2.5. Are you okay with this?
Yeah.
Now denominator, put this number to it, t is 1, right? 1 plus 2 is 3, square is 9, okay? Now check out how much is this one. This way you cannot use our calculator, right? So times 3 both sides. 3 times 3 is 9. 2.5 times 3 is out, that is 2.5. And another 2.5, right? Over 9, okay?
Yeah.
This one is negative 5. 9 minus 5 is negative 4. We put the negative sign. 9 minus 5 is about positive 4 over 9. Okay, total is about negative 4 over 9, which is one negative number. Less than 0. Are you okay with this? This is less than 0 means what? Second derivative is what? Less than 0. The first derivative is what? Decreasing. Are you okay with this?
Yeah.
Right? Okay.
Yes.
If we saw this one, okay, because what? Second derivative is less than 0, then first derivative dy dt is decreasing. Okay? So this one. That's the answer, okay?
Yeah.
Okay. This number 6 already gave, right? This question is already they gave this one, okay? The first derivative is the rate is increasing or decreasing. That's why we have to check right second derivative again, okay? Second derivative is less than 0. The first derivative is already decreasing, okay? If second derivative is positive, first derivative is increasing, okay? All right, this is the number 6. We finished what 2021. Let me check. We finished 2021 non-calculator section. That's right.
Yeah.
4 questions. We finished this one. Now go back to calculator section over here. Okay, we try this one. This is the calculator section. The density of a bacterial population in a circular petri dish at a distance r centimeters from center of the dish is given by an increase, okay? Center is getting away from center, okay? The milligrams per centimeter bacteria, right? Getting increase, okay? In the middle, very only one away 2 away 6 milligrams, okay? All right. So our FR is measured in milligrams per square centimeter, okay? FR for selected variable given by the table. Density of bacteria are centimeters from FR is what is the milligrams per square meter? FR is milligrams. But there is a density of, it is density milligram in bacterial population. It can be calculated by milligrams. A little weird anyway. That is not number of bacteria, okay? Just milligrams. I don't know what that means. Per square centimeter anyway, okay? All right, we can do that. Use data in table to estimate F prime 2 to 5. You are over here. In the middle, we use these two numbers, okay? The rate of between these two numbers in the middle is actually equal to this one, right? That's our definition, isn't it? When R is 2 centimeter over here, another one 2.5. 2 is 6 over here, and 2.5 is 10 over here. our definition, this is the rate. It's okay? But
Yeah.
2.25 in the middle, we're going to use this one, same rate. Okay? Same rate. So what is the slope of this point? A constant slope, okay? That's our definitions. So what's the slope of this one? Average rate of change. Average rate of change over here, right? FR, F prime 2.25. That is approximately, what, I'm going to approximate. Equals what? Slope of this one, okay? So 10 minus 6, y2 minus y1 over x2 minus x1, okay?
Yeah.
That we said what they are almost equal, right? Approximately equal. 10 minus 6 is 4. 2 minus 2 is about 0.5. That is equals to 40 over 5 equals to 8. It's okay? So 8 milligrams, we said what? 8 milligrams per centimeter, okay? Little weird questions, but I think that's fine still. Let me check one more time, okay? That is not number of population. That is not number of population. Check one more time. I think it's okay, right? So anyway, that is milligrams.
Yes.
Okay. It should be number of bacteria. Okay, that's fine. The unit is what is that? Milligrams per square centimeter, okay? Milligrams per square centimeter. Measure what is that? Milligrams per square centimeter over to centimeter again. Wow, this is a little bit complicated. Milligrams per square centimeter. Okay. This unit is milligrams per square centimeter per another centimeter. Okay. This is a little bit weird one. Anyway, that's the answer. Okay.
Yeah.
All right, total mass in milligrams of, oh, that is a mass over here, okay? Yeah, total weight, okay? Yeah, mass, bacteria mass, okay? Yeah, okay. Patrick, this is given by the integral, okay?
Yeah.
Okay, so 2 pi 04 r times FR approximate the value is what? 2 pi 04 r times FR dr using right Riemann sum, okay? They said total mass of bacteria is given by the equation 2 pi times 0 to the 4 r FR dr, isn't it? But FR equation is given only, right? Table is given, right? So we're gonna find out r FR over here, okay?
Yeah.
So first one, when r is 0, what is r FR? When r is 0, I'm going to this one. When r is 0, r FR is 0 times 1, that r times FR, right? 0 times 1 is 0. It's okay?
Yeah.
The first one is 0. Second one, when x is 1 over here, r times FR is about 1 times 2 is 2, right? Okay? This is 2. Height is 2.
Yeah.
When t is 2 over here, I'm sorry, t is 1. T is 2, R times FR is 2 times 6 is 12. It's okay?
Yeah.
That's 12. 2 times 6, R times over here, R times F, right? R times F, 12. Here. Now 2.5, here is 2.5. R is 2.5 and FR is 10. 2.5 times 10 is 25, okay? How high are we? 25. Now, when R is 4, 4 is over here. R times FR is 72, right? 4 times 18 is 72, very high, okay? 72 over here. I'm going to take about this. Now we're going to find this area, okay? When there's no equation, we're going to find what? Right Riemann sum, okay? Right Riemann sum, right side is when you make over here. Right side is, will be height of the rectangle, right? Right side. So this is a rectangle over here. One rectangle, two rectangle, three rectangle, four rectangle. This is overestimation, right?
Yeah.
Because the graph is by increasing, okay? They said by an increasing, okay? By increasing right and Riemann sum is what this will overestimate this much, okay? More, okay? So this is overestimation. The reason is what? The graph of this one is increasing. That's the reason, okay?
Yeah.
All right. So now let's find the approximate value of this one. Okay, that is exactly equals approximate equal this area, right? Sum of this area. Okay, first area is how much? 1 times height is 2, right? So first area is 1 times 2 equals 2. Second area is what? 1 times, this is 12, height is 12, okay? 1 times 12 equals 12. Third one is only 0.5 is the bottom, 0.5 times 25, okay? 25 times 0.5 is 12.5, okay? The next one is what? 4 minus 2.5 is 1.5 now. 1.5 of times 72, right? So 1.5 times 72. This one, you can use a calculator, okay? Use a calculator. How much is this one? Can you have a calculator?
Yeah.
Okay. 108, right?
Yeah.
Okay. So this one is 108. Sum of this number is how much? Give me the number over here.
Hold on.
Use your calculator, okay?
Okay. Sorry, 1 second. 134.5.
134.5. Okay.
Yes.
But this is the area, right? 2 pi, okay? We multiply. So finally, the area of this bacteria, okay? The mass of bacteria is what? 2 pi times, I'm sorry, we calculated already. 2 pi times 134.5, okay? Just approximate how much? 3 decimal place. Are you okay with this? If they didn't say any specific number of decimals, we usually write 3 decimal space, okay? How much this one? 2 times pi and times 134.
Yeah.
Okay, I'm gonna do 2 pi. 2 pi times 134.5, okay?
Okay.
845.088. 800.45.88, 088, the decimal, okay? 3 decimal is okay.
Yeah.
It is okay? Yeah, that's the answer, okay? Choice C, is the approximation found B the overestimate, underestimate? Oh, we did already, okay? Overestimate, right? Of
Yeah.
total mass of bacteria, okay? Explain what is that? The graph is what? Increasing, okay? The graph is over here, continuously increasing, that's why, okay? You can write down over here. Overestimate
Mm.
goes up, the graph is increasing. Okay, you can write down this one, that's enough, okay?
Yeah.
Okay.
Mhm.
The next one is number D. Okay, C, we did it. We did all this. D is what did that? That's the bacteria and petri dish for the radius is what, between 1 and 4 modeled by function G defined what? We have another function of here, G over R. New function, okay? New bacteria. 2 minus 16 cosine 1.57 and the square root R and cube.
Yeah.
Wow, so complicated. 16, this is a cosine inside, okay? This is a cosine inside. For what value of k? K should be between 1 and 4 equal to average value of GR, okay?
Yeah.
What is the average value of GR? Can you find the average value of GR first?
Yeah.
Okay, now let's find the average value of GR, okay? I'm gonna write over here. What is the average value of GR? In this
Um,
interval, okay?
yeah.
1 and 4, okay? So the bottom is about 4 minus 1, again 1 over 4 minus 1, that is 3, okay? After that, 1 to 4 integral, okay? G is about 2 minus 16 cosine, 16 is outside, right? 16 is outside,
Yeah.
16 outside. Over here, cosine 1.57 square root R and the cube, okay? And dr, isn't it?
Yeah.
Okay? Right. Wow, this one is, we need a lot of work. Okay, now let's find this one first, okay? So we have to use our calculator. One over 4 minus 3, we divide what the base, okay? The length of base is about 4 minus 1 is 3, okay?
Yeah.
So over here, I'm going to do 1 over 3, 1 over 3 first. After that, we're going to put in there integral, okay? Integral over here. We take all the area from 1 to 4. 1 to 4. And integrand is 2 minus 16, we need the parentheses. 2 minus 16, and the parentheses again, cosine, parentheses again, 1.57, and the square root R outside, we have 1 2, and the squared, that's a cube over here, right? And cube, the last one is a closed final branches, okay? That's from here, here and here. After that, we take right dt, it's okay?
Yeah.
So I'm sorry, dr, right? We use the r, I'm sorry. We use the dr. How much? 9.876.
Yeah.
Okay, 9.876. I'm going to do 9.876. Okay, yeah, that is the average. But over here, density of bacteria, okay, G defined this way. For what value of K, for this one, using this one, okay, for what value of K, you can put this number K in the R over here, right?
Yeah.
So what is G over K? G over K is what? Put this number K there. 2 minus 16, okay? Put this number instead of put in the K. 16 cosine 1.57 square root K and cube. That's right, right? Inside of here. Okay, this is, and then cube. That is G over K, okay? So when you have this one should be equal to 9.876, isn't it here? Average value, okay?
Yeah.
Now how can you solve this one? We have to make two graphs. This is the y1 graph is this one. y1 you make a graph of this one. 2 minus 16 cosine 1.57 square root k. You can use square root instead of k, okay? The variable is k. K and cube and cube, right?
Yeah.
Inside this cube, outside of here. Oh, this is so complicated. Closed because this is inside. 1, this outside, and the cube. Okay, that's fine. This is y1, and the y2 is the constant functions 9.876. So we're gonna find the intersection, right, to find the value of k. Oh, this is a little complicated. Okay, now let's find the graph over here. y1, y equals 2 minus 16, over here. Cube, right?
Yeah.
Before cube. Yeah, but I'm going to take this as a k, okay? Because we replace it with a k. It doesn't matter anyway. The graph is this one, okay? This is the graph. Very weird, right? From here. Wow. This way, okay? The next one is, this is the value of k, right? We're going to find the value of k. For this value of k, y is 9.876. So second is y2 equals 9.876. Where is the intersection over here? K equals 1 and 4 here. 1, 2, 3, and 4, okay? Are you okay with this?
Yeah.
K equals 1 and 4 is about from here to 4 here. Before 4 here, right? Before 4. So we have only one intersection over here, right? That's point. Are you okay with this?
Yeah.
This is equals 0.445.
Mm.
1.57. This one is complicated. Let me check the answer, okay? Nothing different. That's correct. Just give me a minute, okay? I'm gonna check that in my smartphone. That is a college board.
현재의 부인이 될 거다.
Okay, in the answer key, oh, we have A, B, C is correct, but this we have different. D is over here 2.497. When I make a graph over here, it's going to be 0.445. I don't know here, right? I'm sorry, not this one, okay? This point, okay? Y equal 9.x, okay? This point is the answer. How much? This one. 2.497, that's correct. Okay? Are you okay with this over here? That is intersection, right? When the k value is what? 2.497. That's correct, okay? This I got the right wrong number over here. Because we're gonna find this intersection over here, okay? This is not. This is the same as before, just before. What is that? Let me see. This is 9.86. But over here, when you find the intersections, the value of k must be equals 2.497, okay? 2.497, that's fine. That's nice, okay?
Yeah.
Over here, 2.9497, that's fine. That's nice, okay? That's C. But C is a little hard to make a graph, okay? But still, you can try A and B, 2 questions, or more than 3, okay? 3 questions is okay too.
Yeah.
Are you okay with this?
Mm.
All right, okay. Yeah, that is question number 1, right? Okay.
Yeah.
Now move on number 2 there. Take a look at number 2. A particle P is moving along the x-axis. The velocity of particle P at time t is given by this one. This is particle velocity, sine t to the 1.5. Very weird functions. Only what t equals 0 to pi. At time t 0, particle is at position x is 5. Position is y, x is t equals 0. The particle is at x equals 5 there, okay? That is the initial.
Mm.
So if another particle it moves along the x-axis, the velocity is the velocity of particle q at time t is given by this one. This is particle p, particle q over here. But this is more complicated. At time t is 0, the position is 10, right? Q position is, I think this is position xp. Position q, okay, at time t equals 0, position is 10 over there, okay? So when you have the line, this is 0, particle p, okay, we start from here, 5 here. This is particle p there. Particle q is where is it? 10 over here. This is particle q, right? From here, they're gonna start, okay? Are you okay with this?
Mm.
All right, now let's find the particles P and Q at time t is 1, okay?
Yeah.
But time is 0 is given by the functions, but time is 1, we don't know, right? Okay. So how can you find time is 1?
Yeah.
Okay, take a look here. X particle time is 1 equals how much? X particle time is 0 over here, right? 0 is 5. From here, we're going to change. That is a fundamental thermal calculus, okay? From 0 to 1, okay? Only 1 second. During 1 second, change in rate, okay? You can add all change in rate. How much? This one. Sine t to the 1.5 dt, isn't it?
Yeah.
Particle Q changes one is what? Particle Q initial we start to 10, okay? This is a 5, this is a 10, okay? And plus 1 to 2, the particle velocity is what? T minus 1.8 times 1.25 T and dt. Is okay?
Yeah.
Yeah, that is a fundamental thermal calculus. We're gonna find this, okay? This is a 5. This is a 10, okay? Now we use calculator. Without using calculator, we never solve this, okay? It's very hard. So xp over here, xp is 5, okay? At time t0, that is position is 5 there, 5 plus integral. I'm going to take an integral about this one. Integral is from 0 to 1, okay? 0 to 1. 0 to 1. Now inside is a sine parentheses t to the, I'm going to do time t to the 1.5, t to the 1.5. After that, out. And the dt, okay? Where is this one? 5.370, right? 5.371. This one equals x to the 1 equals what is that? 5.371 there, okay? Are you okay with this?
Yeah.
Now particle Q there. Particle Q at time t is 1, okay? This one. Check it out. We checked out this already. xq and initial at time t0, xq is what we start from 10, okay? From 10 over here plus borrow this one. Integral from 0 1 1 t parentheses t minus 1.8 and times 1.25 and to the t, right? To the t and parentheses outside the parentheses.
Yeah.
It's okay, right? And the dt, where is it? 8.564, right? Yeah. 8.564. That's the answer, okay? So, at time t equals the position of xp, p is what is the xp, you can use this, okay? xp equals 5.371 and position particle q is at time t equal 1, 8.564, okay? Right. Second one is particles P and Q moving toward each other or away from the other at time t equals 1. Okay? They are moving toward or each other. Away from each other. Toward means what? P is moving here, Q is moving over here, right?
Yeah.
Away is what? This way. So we're going to check their velocity at time t equal 1. Velocity is positive, move to the right. Velocity is negative, move to the left. Okay? So velocity Vp at x equals 1. Okay? I'm going to check it out. So velocity particle P at time t equals 1. It's okay?
Yeah.
How much? Sine? T is 1 to the 1.5 is still 1, right? Sine 1 equal how much? Sine 1 equal positive, right? Are you okay? Sine 1. That is radian, okay? That is 57.3 degree, okay? It's going to be positive. How much? This is radian, okay? Yeah, radians. So sine 1 is what? 0.841. 0.841. That is a positive. That is a move to the right. particle q at time t is 1. 1 minus 1.8 times 1.25 to the 1, okay?
Yeah.
This is how much? 1 minus 1.8 is what? Minus 0. Okay, find out by calculator, okay? 1 minus 1.8 and 1.8 and close with times 1.25. Negative 1, right?
Yeah.
Negative 1 is what? Minus sign move to the left. So P is moved to the right, Q is moved to the left. They are moving toward each other, right?
Yeah.
Are you okay with this?
Yeah.
All right, choice C there. We did the number A and B, okay?
Yeah.
C is find the acceleration of a particle Q at time t1. Is the speed of particle Q increasing or decreasing, okay? Speed. Now we're going to find that time t equals 1. We did already, okay? At time t equals some particle Q is what? Negative, isn't it? At time t equals 1, we already got velocity, okay? Particle Q velocity 1 equals negative 1, right? Negatives, okay? Now we're going to find the acceleration. Acceleration is what? Derivative of this one, okay? P, Q, T, acceleration, how much?
Yeah.
The first one derivative is what? T is 1, right? 1.8 constant. 1 times 1.25 T plus first one don't touch T minus still 1.818 and derivative of 1.25 T is how much? Exponential, right? 1.25 T, right? But we multiply ln 1.25, isn't it? To understand AT derivative what? AT times ln A, right?
Yeah.
A is what? 1.25. Now put this number 1 there, okay? Put this number 1. That is what? Acceleration particle Q at time t is 1, right? Now we're going to find this one. T is 1 is 1.25 plus T is 1 is what? 1 minus 1.8. T is 1 is 1.25 and the ln 1.25, okay? That is the value of acceleration at time t is 1 for the particle Q. 1.25 plus 1 minus 0.8, 1 minus 1.8 and times 1.25 and times ln 1.25 too. How much is 1.027, right? 1.027. This is positive. Velocity at time t equals 0. At time t equals 1, v particle 1 is what? Negative. Acceleration particle q is what? Positive. There are different signs over here. That means what? The particle q is what? Decreasing in speed, right? The speed is decreasing. From here, they have opposite side. The speed is decreasing.
Yeah.
The reason is what? Velocity and acceleration have opposite sign, okay? You can explain, okay? Because what? They have opposite signs. Okay? Well, different size is okay too.
Yeah.
One is plus, minus, this is plus, okay? All right, so speed is decreasing.
Mm.
Okay. Okay, the last two questions. Find total distance traveled by particle P over time interval 0 pi. Okay. Velocity. Time interval is what? Integral velocity, right? Where is the velocity over here? Take a look. Velocity part per Q is here. Vp, this is choice, okay? Vp particle T sine T to the 1.5, okay? That's the velocity, but travel distance is what? Sum of all distance, right? To the right, to the left, the right, doesn't matter, okay? Anyway, we're gonna add all the distance. From where what? T equals what? 0 to pi. Are you okay with this?
Yeah.
Now let's find the graph of velocity, okay?
Mm.
I'm gonna, this is the graph over here. Okay, take out. Okay, so I'm gonna use the velocity graph. Vp equals y equals sine and t to the what? 1.5. Okay, 1.5. So we're gonna find this one is from 0 to pi. Okay, we're gonna cut off the other one. I'm going to do 0 to pi.
Mm.
0 and t and less than pi. Cut off. Okay, cut off. This is it. Okay, this from here to here, right, and move to the right until 2.145. Okay, move to the right. After 2.145 up to, this is about pi, okay, up to pi over here, right, 3.1 pi. Then it move to the left. So we're gonna add, right, all this area, okay, all this is under this curve is what, this travel distance to the right, this one the travel distance to the left. It's okay.
Yeah.
So just a moment, I'm gonna copy this one, okay, to make. This is the graph over here. From here up to down, okay? And this. This is pi. This point is 2.145 and 0, okay? It is the highest point, it doesn't matter. So this area and the other area, okay? That the distance one, this is move to the right. Okay, with this one, move to the right distance, this is D1. After that, move to the left D2, right? But travel distance, we're gonna add this one, okay? All right, now let's find this graph. The first one is we take integral of this one, okay? So integral from 0 to 2.145, okay? 2.145. This one is sine t to the 1.5 and dt. It's okay?
Yeah.
And the plus, the next one is a minus of it. So take right, make a positive, right? Absolute, okay? Using absolute, you can make a positive 2.145 to pi, and the still sine is what? T to the 1.5 t.
Yeah.
But this one is the absolute value, okay? Because inside the number is negative, okay? Okay, now we solve this one.
Mm.
First one is integral again.
Yeah.
Integral over here, 0 to up here 2.145 sine t to the 1/2. I'm going to do some copy of it, okay? Copy this integrand and the dt. Is okay? Yeah, that is distance. Second one is we're gonna use I'm gonna use the absolute value of it, okay? Absolute value is okay. Absolute value and the integral again. It's gonna be almost same as this one. Integral over here. Okay? But this times move to the left is what? 2.145 to the what? Pi, right? This is a pi. It's okay? That is what move to the left. Okay? Still same functions. So all together, this is out. Up, 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 up. Oops.
Yeah.
So this one is, that's right? Yeah. So total is 1.931. That is the total distance. Okay? That is equals to 1.931, right? 931. Okay, the other is okay. Less than zero. That is total travel distance. Are you okay with this? Just give me, okay, let me check the answer, okay? Just. A is okay, B is okay, and the C is okay, and D is correct, okay? Yeah, this is correct. Okay? So, actually, the answer in the college board, okay, very hard to understand, okay? So try to use, okay, this solution, okay? They didn't solve this way, okay? They skipped a lot of steps. Are you okay with this? Okay. Anyway, I'm gonna send out this, the class work and the video link together, okay? Okay. So, in a minute, okay, I'm gonna send out the link and the work together. I'm gonna stop here.